Hi, welcome to Friday Forum. Today is December 12th, 2025. This is the 235th Friday Forum in the series. The series is hosted by ICLR, the Institute for Catastrophic Loss Reduction. We're Canada's leading source for disaster resilience knowledge. Our mission is to make Canada more resilient to natural disasters. Each month, we present recent research related to that mission. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. I'm speaking to you from London, Ontario. This place is on the traditional lands of the Anishinaabe, Haudenosaunee, Lenape, and Ottawandaron nations. Last month, UC Berkeley professor Michael Goellner told us about a computer model of wildland-urban interface fires. The UC Berkeley model simulates both the wildland side and the urban side of the interface, and that's a first. If you missed it, you can find the recording at our website. You can find the video, the speaker's deck, and transcript at www.iclr.org/workshops. You can find all our other Friday Four there too. In next month's Friday Forum, we're going to hear about building codes and construction costs. Our speakers will be structural engineer Brian Potter and economics professor Dr. Chad Syverson. They're going to talk about how code requirements affect construction costs. They're finding weak correlation between the two, which suggests that greater resilience for new buildings doesn't necessarily reduce affordability. After the presentation, we're going to change up our Q&A from usual dialogue to a panel discussion. So that'll be interesting. That's going to be on Friday, January the 9th, 2026. Today, I'm very pleased to bring you ICLR's Director of Research, Dan Sandink. Dan's going to brief us on the outcomes of our Resilient Homes Task Force. The task force convened builders and insurers to produce guidance for above-code design. The guidance comes in the form of good, better, best checklists and supporting materials. I am frankly amazed by what Dan and the task force have accomplished. To me, their most notable accomplishments have been this. They got builders and insurers to agree on clear, practical, and effective guidance for above-code resilient construction. That kind of meeting of the minds is rare. And it's necessary. It's necessary if Canada is going to decide as a society to solve its resilience problems. The leading stakeholders have to agree on technical details, and with consensus on technical guidance among the experts, legislators can turn the guidance into policy. Now, before Dan begins, here's our agenda. Our webinar is going to last 90 minutes. Our speaker will present for about half that time, then I'm going to moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I'll try to pose your questions to Dan in the order that they appear in the Q&A box. If we have a lot of questions, I might only pose your first question, then I'm going to move on to others, then I'll circle back to your additional questions. Our webinar is recorded. As always, ICLR is going to post our speakers' slides and a link to the video in the next day or so. So if you have colleagues who couldn't attend today, let them know. You can find the recording and the deck and a transcript at www.iclr.org/workshops. And with that, I'll turn it over to Dan.
Great. Thank you, Keith. Thanks for the opportunity and your kind comments just now. So today I'm going to talk to you, this group, about some of the more important outcomes, I would say, of the Resilient Homes Task Force initiative that we've been running with the Canadian Home Builders Association over the past just about 2 years. I'm going to focus specifically on more of the technical outcomes, the guidelines that we produced with guidance of the task force in a subcommittee that I'll talk about, and also a series of field trials that we've initiated this year to test and demonstrate resilience practices that we are promoting through our guidelines. So I just really wanted to quickly introduce ICLR's work on residential construction. I know this group is familiar with ICLR generally, but this specific stream of work has been going on for about 20 years now. And the task force is an example of our work on implementation of resilience options with industry partners. I would break our work on residential construction into 3 categories. The first is understanding vulnerability and risk reduction options for residential buildings. At ICLR, due to the guidance that we received from our membership and our partners, we focus on low-rise residential construction, which is regulated in provincial construction codes and through the National Building Code in Part 9. So I'll say Part 9 structures often, but what I mean is low-rise residential buildings, 3 stories or less, typically wood frame, single-family, townhouse, semi-detached. That's the kind of building that we focus on here. So the images at the top of my screen are examples of some of the work that we have been involved in with respect to understanding vulnerability and risk reduction for high wind, for urban flood, for wildfire. This has been a big focus of our work over the past 20 years. About 10 years ago, we had the opportunity to become involved with several projects at the federal government level that focused on developing standards and guides for resilience in construction. And so that was an opportunity for ICLR and our partners to take the more academic work, the lab work on testing of performance of buildings, and start to convert it into construction language, some materials that potentially could be adopted by the construction industry. And examples of that work are on the bottom left. And I'll talk about a few of the outputs of that work that relate to the task force outcomes as well. And then more recently, I would say within the last 5 to 10 years, we've been encouraged by our membership and our board of directors to identify opportunities to implement resilience options. So we're moving from research to standards and guides to implementation. We're a small organization, so we are typically conducting pilot and field trial projects or working with partners to identify opportunities to increase capacity of industries to apply resilience practices. And we've got a number of projects ongoing here, but I'll talk today about one of the more significant ones, which is the Resilient Homes Task Force. So one of the foundational issues that we're dealing with over the past few years is the fact that we have guidance available for the insurance and building industries on reducing risk of the built environment, of homes, of low-rise structures, to the impacts of some of the most important drivers of loss in Canada, including wildfire, urban flood, high wind, hail. But that guidance typically has not been implemented. There's very few examples of where this work has been implemented. So to take an example, we've got the National Wildfire Guide for Canada, developed by NRC and released in 2021. We've got various standards focused on urban flood protection, like CSA Z800, guidelines on stormwater and wastewater design, system design to reduce risk from extreme events. A few years ago, we were involved in the CSA S520 high wind protection standard for Part 9 buildings. And for many years, we've had guidance documents on or testing standards for roofing products to help performance in hail events. So despite the availability of this material and a general level of awareness in terms of what part of the country is vulnerable to these hazards, we've seen very limited uptake to date. And I should just clarification, I'm going to focus on urban flooding today, and that includes extreme rainfall flooding in urban areas that typically drives surface water flooding from stormwater, sewer backup. This is sort of a situation where we have extreme rainfall that exceeds stormwater system capacity or affects areas where there is no stormwater system causing flooding, as opposed to coastal or river flooding, which is really more of an engineering issue. And we're focused on more simple prescriptive measures that can be advanced through the industry. So that's the kind of flooding I'm focusing on today. But the point here is we know where in Canada we're at risk, and generally we know the technical guidance or we have the technical guidance to reduce risk, but we really haven't been applying it widely. So we approached Canadian Home Builders Association a couple of years ago and proposed that we work together to find solutions to increase capacity of both the building and insurance industries to apply resilience practices for buildings, for new construction, for renovation, for post-loss rebuilds. And so we worked with CHBA to define what we called the Resilient Homes Task Force. This is a group of insurance industry executives and building industry executives, largely building company owners or senior staff, who helped us identify a roadmap to move from isolated application of resilience practices to more mass adoption of resilience practices in these two industries. The task force is composed of, as I said before, building industry executives and insurance industry executives. Our co-chairs are from the building industry, Alex Miller, who is CEO of Big Block Construction, based in Saskatchewan, and Susan Pinwarden, who is Managing Director of Personal Lines at Aviva Canada. And with the task force early on in our work, we worked with them to develop this strategy document, which is essentially a roadmap for moving from isolated application of resilience options to mass market application of resilience options. And I'm going to focus on a few outputs of this work today, notably the guidelines and the field trials. There are several other outputs we can talk about at some point in the future, but these two major outputs were considered by the task force to be the most important outcomes of the last couple of years of work. I'll also note that we did present a Friday forum in July on market research projects that we conducted under the task force, and you can find a recording of that presentation on the ICLR website, and the link is there as well. So first, one of the first things that the task force identified as a barrier to implementation of resilience practices in the field was the technical nature and the complexity of the standards and guides that we had been involved in producing over the previous 5 to 10 years. Guides like the NRC Wildfire Guide, the CSA S520 for high wind, Z800. We were finding a lot of resistance to application of these guidelines just because of the nature of the presentation of the options in those standards. It was highly technical, in many cases required input from fire engineers, structural engineers for application. And it's really not in the appetite of many builders, they're telling us anyway, to apply options in this fashion. So one of the first things they set us on was a project to prioritize resilience options and develop what we ended up calling a tiered resilience options. We call it good, better, best. Good is a basic level of protection for buildings that addresses recurring vulnerability. Good level measures are measures that are low risk to builders. They're measures that are technically mature. They've been in the market for a period of time. Sometimes they're referenced in code, but they're just not applied universally across Canada. There are incentives available in many cases by insurance companies, and they can be applied at comparatively low cost and complexity by a builder or a restoration contractor after a loss. At the far end of the scale, the highest tier is something we call best. And the best tier would involve full application of the standards and guides that I mentioned before. The emphasis of the best tier is on performance of the building during extreme events and not on complexity or practicality or cost of resilience options. The focus is on ensuring that a building can perform under a specific load that might be prescribed in the standards. And in many cases, the solutions that are presented in the best category have not been applied in the field. They're still in development. They're more experimental, but the goal of the best category is full application of those standards. And then we have a middle tier that we call better, which is kind of a compromise between these two ends of the spectrum, where we are applying measures that are reasonable for application in the industry, but are not going as far as the measures that are identified in the standards. And I can talk a bit more about what that means through application of the field trials in a minute. So we relied in the development of our guidelines, the Resilient Homes Task Force guidelines, on existing standards and guides that we and others had been involved in developing over the past 10 years or so. We have a pretty rich set of resources across most of the hazards that we're focusing on. Basement flood, urban flood, high wind, wildfire, and notably, for example, for basement flood, the primary standard was CSA Z800, but there's an additional set of documents and guidelines that we folded into this work as well. For high wind, the primary standard was CSA S520, but there is additional documents like the benefit cost assessment conducted by Keith Porter on that standard recently as well. For wildfire, the core document was the NRC Wildfire Guide for Canada, and also practices that were advanced by IBHS and others that did involve prioritization of options, notably for retrofit in the US. But there's another set of documents there. So we have pretty good guidelines for basement flood, high wind, and wildfire. We had a good set of documents to draw on. And that's a bit different than the situation for hail. So right now, we have testing standards for hail for roof cover and PV panels, but not really for other elements of the buildings like siding, windows, downspouts, gutters, and so on. So we had to develop a lot of this information for hail protection from scratch with the input of our colleagues from the Northern Hail Project and Travis Engineering. So a lot of the content in the hail guidance that I'll explain later is new content. Another important input for our guidance document. So the concern of the task force is that we produce practical guidance that can be adopted readily by a building company, by trades, by a restoration contractor, without a lot of interpretation by outside experts. In order to help with this, we put together what we called a pilot working group. This was more technical staff from building companies and insurance companies. So we had a general technical support group with builders like Mattamy, Minto, Avalon, RDC, Doug Terry Limited, Third Generation Homes, medium-sized and tract builders to help guide us how to present resilience practices in our guidelines and make sure that it's usable in the field. And we also had input from insurance partners, Aviva, Curo, and TDI as well in this task group. We also brought in expertise from supporting groups like RDH, Fire Smart Canada, for wildfire, for high wind. We worked closely with Sarah Stevenson from Canadian Wood Council, Doug Terry and his team at Doug Terry Limited, who had been leading a lot of this work for the construction industry in Ontario. For hail, we worked with the Northern Hail Project, Travis Engineering, as I mentioned before. And we also had input from large loss teams from some of the participating insurance companies like cooperators who provided input to our guidance as well. And then we had some sponsors. This work was sponsored by National Research Council, Standards Council of Canada, and we also received sponsorship for pilot projects from Aviva and TDI as well. And I'll talk about that later on. Another important input for the guidelines was the field trials, and I'll talk about those in more detail shortly. But we did work with builders to apply the resilience practices in the field and adjust the recommendations based on application by builders over the past few months. Another set of information that was important was our insurance and building industry surveys. So we worked with CHBA and our partners in the pilot working group to put together industry level surveys on resilience practices. And so what we did in these surveys is we had an online survey. We took each of the resilience practices that are included in the major standards and guides, plus our new hail guidance. We broke those out and presented a series of questions to building companies and insurance companies concerning cost, availability of materials, practicality, willingness of trades to implement measures, and notably from the insurance industry, the expected impact of each of these options on claims frequency and intensity. And the idea behind these surveys, aside from just generating information on each of the resilience practices that we are searching to promote, is to prioritize options further for our tiers. And we use the results of these surveys to move resilience practices that builders reported that they were likely to implement in the next 5 years, and that insurers reported would reduce the impact of disasters in terms of claims frequency and intensity into lower tiers, so into the more basic tiers of our tiered guidance. The tables on the bottom of the screen are a summary of these inputs where we inputted the outputs of the surveys into this impact matrix, where and then we're presenting this information. The more green you see, the more likely builders are to implement the measures, and the more impact the insurers reported that the measures would have on reducing claims frequency and intensity. And so again, that helped us prioritize options for our tiered resilience measures. We conducted these surveys from November 2024 through August of 2025, and we had about 141 responses, half from the building industry and half from the insurance industry. The building respondents were largely building company owners, and they were from across Canada in both cases. Another sort of core piece of advice that we were acting on from our pilot working group was how to present options. And so this is a summary of their most important advice in terms of how to present options in our guidelines. They told us to use simple language, avoid technical terms like don't say 8D nails, just give a nail length, for example. Don't reference testing standards if you can avoid it. Assume users of these guidelines don't speak English or French. In many cases, trades on site are subcontractors and are not English or French speakers, so they should be interpretable by people despite their language. We were advised to use 3D drawings, pictures to the extent possible, so reduce reliance on words, use pictures to the extent possible. And we were also pointed to the construction industry resource called Construction Instruction as a model that we should be working toward in our resilience guidelines. So this is the current version of our outputs, and I'll go into a bit more detail about what these look like. But we've developed checklists that are broken out into our tiers for each of our core hazards: high wind, pluvial flood, hail, and wildfire. They are each standalone checklist outlining resilience options for the good, better, and best tier across these hazards. And so a builder can, or a restoration contractor or insurer, can take the checklists and easily work through potential resilience options. And I'll give examples of how we've applied these in the field with our field trials shortly. Aside from the checklist, we have additional content. We have introductory material. I'll talk about that in a minute. We have the checklists themselves. We have a large set of technical sheets, and then we have documents that outline insurance incentives. So the introductory material, standard introductory material outlining what the task force is, what our objectives were, and also being clear that we intend to iterate these guidelines. We want to update them based on feedback from users over the coming years. So what we're releasing now are the first versions. We will continue testing them in partnership with builders through field trials, receiving feedback from insurers and so on. And we'll update these guidelines over the years. So we wanted to make that clear in our introductory materials. We also, as I mentioned before, have included insurance incentives information. So one of the things that we've learned from working with CHBA and our builder partners is that there's an expectation that application of resilience options in buildings will somehow affect insurance coverage. And there's a perception that insurance premium should be reduced because of application of resilience options. So one of the things that we had to work with the builders and the insurers to help communicate is that application of resilience measures for any given policyholder could affect premiums, but it could also affect deductibles, sublimits, availability of coverage, depreciation schedules. And so you may see an incentive, but not in the form of a clear premium reduction. It might be a combination of these mechanisms. And it provided several examples. And part of the work with the task force over the past couple of years was just keeping track of which insurers were offering incentives in which form and trying to communicate that to builders. And of course, many insurers are offering Build Back Better subsidies. And that's something that we also wanted to communicate to potential users of the guidelines. So in our set of guidance documents, we'll also be releasing very simple primers on insurance incentives that outline each of these mechanisms for the impact of resilience on a given policyholder. And the idea here is to educate builders who might be using these checklists to help them potentially market resilience options that they could include in new construction. Unfortunately, it's difficult to communicate these different mechanisms of impact on insurance coverage. And so that's a challenge that we'll have to continue to address over the coming months and years working with the building industry. I mentioned the checklist earlier, but this is an example. So this is the Wildfire Good, Better, Best checklist. This is really where we're getting to the very simple presentation of options that I mentioned before that the pilot working group encouraged us to pursue. So we have the simplest presentation possible of each of the resilience options in our checklist, such that a builder can take the checklist, sit down at their desk, look at the plans for an upcoming build, and check off the options as they go through the checklist to see the extent to which they comply with resilience practices that we're recommending. And these checklists, as I mentioned before, are backed up by technical sheets. So each of the resilience options presented in the technical sheets have a supporting technical sheet that outlines more information about that resilience practice. And so the technical sheets is where we get into reference standards, into material selection, into additional guidance, the impact of the resilience options, why they are being promoted in our checklists and so on. And also technical guidance in terms of implementation of that resilience option. We've also included in the technical sheet, based on feedback from our pilot working group, some critical information that we get from builders, notably builders, but also insurers and restoration contractors, on key factors that might affect the decision of a builder to apply these measures. That includes the expected loss reduction benefits of each measure, the cost increment over typical practice, installation difficulty, and product sourcing. So for every single one of our technical sheets, if you can see my mouse here, we have very simple tables outlining the impact of the measure in terms of its expected benefits, the cost increment, the installation difficulty, and product availability. And these are the major questions that we get when we're looking to apply these measures. So we wanted to address those right off the bat in the technical sheets. And that information is based on the industry surveys that I mentioned before. So this is an example of a presentation of a basic checklist and the technical sheets. This is our good tier checklist for hail and the accompanying technical sheet. So the intention here is that a building company owner and executive could take the checklist and read very quickly the resilience measures and understand what potential measures they could apply. And if they want more information, they can go to the technical sheet that provides technical standards, what to look for in technical specifications if you'd like to select specific materials, and also diagrams of what those practices look like as applied in a building. And so this is the good tier for hail. This is really the simplest checklist that we have. And this is an example of the better tier. So building on that good tier, adding additional measures with the supporting checklist. This is the way that this information will be presented to the building industry. So there are about 130 of these technical sheets. Right now we have released basement flood, hail, and high wind in English. They'll be translated as well. They're available at this website, and we will update, as I mentioned before. So go and check periodically for updates at this website. And if you have feedback, if you're looking to review or apply these guidelines, we'd be very happy to receive your feedback as well. So now moving on to the field trials. And so we wanted to not sort of develop our checklists, our guidelines based on meetings and desk-based assessments. We wanted to go out into the field and work with a builder and apply the checklists, apply the resilience guidelines to understand whether they could actually be applied in practice in the field. So the goal of our field trials was not necessarily to apply all of the resilience practices. So we have a long list of resilience practices, over 100 potential measures that could be applied. The goal was to have the builders work through each of the practices and provide us with feedback in terms of their practicality, the impact on the potential sale of a building, how they interact with other components or other systems of a building, to help us refine the guidance and present it in a more usable way. And this information, again, helped us define good, better, best options. The easier practices, the more practical practices, the practices where we didn't run into major cost or supply issues, were moved into the more basic tiers because they're more readily available for application by the industry. And the goal of these field trials was really to understand constructability and clarity of guidance as opposed to application of all of the resilience options. So the field trials relied on an integrated design process. We actually had a call for interest through CHBA last November, about a year ago. We had a number of candidates submit applications. We had some filtering criteria, like we wouldn't work with a builder that was building in a defined floodplain, for example. And after we selected the builders, we went through a series of meetings. We sourced their specs and diagrams for an upcoming project, and we worked through those specs with the builder, made our resilience recommendations. We worked with our partners to make resilience recommendations. And then we held a design workshop with each of the builders. That was in January and March of this year. And we went through several exercises. First, we introduced the concepts. We introduced the intent of the pilot projects. And then we had the building participants break out into groups and talk about, again, broken out by resilience option, the design impact, the constructability, the potential impact on the owner of the building, the cost of the measure, any potential maintenance issues that you might run into applying these measures. And then we ranked each of the measures in terms of priorities for the project in question. And we are working with Big Block Construction on a wildfire pilot near Fernie, BC. We're working with Avalon on a hail and wind pilot in Calgary, and Empire on a wind, basement flood, and hail project in Southern Ontario. And I'll provide some detail on each of those projects. So first, I'll go through quickly where we are on these pilot projects. They're not complete. The builds are underway, or in some cases, they haven't started yet due to permitting issues and so on, not related to our measures, but other issues. So first project that we started was with Big Block Construction. This was a site near Fernie. It's on the Fernie Alpine Resort in near Fernie, British Columbia. This is a wildfire demonstration project. The building itself is located here, very close, or it abuts an area of extreme wildfire risk due to vegetation, fuel type, and slope. It's a high-risk area. And this, the building on the bottom left, this is the rendering of the building that we're working on with them. So in this case, we worked through, as I mentioned before, each of the resilience options for wildfire. This is drawn directly from the NRC Wildfire Guide, presented under our best tier. In this case, this was these buildings are already partially in compliance, not because of wildfire resilience, but because it's an upper end development targeting sort of the upper end of the market. So it had fiber cement siding, steel roofing, stone veneer siding, and so on. So we'd already achieved a lot of our wildfire resistance practices just due to the aesthetic desire of the builder in this case. The table on the left is each of the resilience practices that we worked through with the builder. The green cells indicate the practices that they intend to apply, and then we have some initial costing estimates for those measures. The yellow highlight are measures that they are likely not going to apply. So the green measures include things like Class A roof assembly. That was going to be applied anyway. It was steel roofing, non-combustible siding, and so on. These are fairly acceptable or practical measures that were available to the builder that added not a huge increase in cost. But the measures that we had some resistance on were windows, fire resistance ratings for walls, addressing garage doors. These were expensive practices and somewhat technically complex. And so they were going to add a lot of cost to this build, and so likely won't be included. And also, due to the phase of construction that we became involved in this project, some of the practices would result in a slight change in the building footprint, and so we couldn't apply in this case. But the conclusions were that a lot of the practices were practical, and we had very good buy-in from this builder, and they in fact look to apply these practices by default in future projects. The next project is the field trial in Southern Ontario. So in this case, we're working with Empire Homes on a single-family detached home in Caledonia. This is a site they're building out with several hundred homes. This home was already a demonstration home where they were demonstrating net zero, embodied carbon, indoor air quality practices. And resilience was added later in the design process, so it added a bit of complexity in terms of application of resilience, but we were still able to achieve a lot of our goals. And I'm going to present some numbers here that include costing for resilience practices. I should highlight that because it's a demonstration site, there's no competitive bids for application of these measures. So the numbers are likely a bit on the high end. but it's an indication of the potential increase in cost for some of our resilience options. So again, we had an IDP session with Empire back in March. I should acknowledge some of the partners in this field trial, Dr. Sarah Stevenson from Canadian Wood Council, Simpson Strong Tie, Brent Bunting, the LP Smart Side team, ICO, Simpson, LP, and ICO were all donating product for this project as well, roof cover, siding, and structural connections. So one of the first things that we did is we wanted to understand if there was a flood exposure in this site. As I mentioned before, this is near Caledon. We use the Grand River Conservation Authority flood maps to identify flood exposure. It's not in a floodplain as defined by Grand River Conservation Authority. We also used Professor Simonovich's future flood forecasting tool. It's even under a future scenario using RCP 8.5 and a 500-year return period flood. It's not vulnerable to river flood. However, our insurance partners informed us that this site is considered vulnerable to pluvial flood and sewer backup. And that's because of historical flood occurrences in this area. So this is south of Hamilton. We've had a lot of flood events in this area in the past on Hamilton Mountain, Binbrook, and so on. So it is considered to be high risk by the insurance industry for pluvial and sewer backup flood risk. So because of the exposure to flood risk, we wanted to incorporate as many basement flood protection practices as possible. This is an example of application of our basic or good tier practices for basement flood protection. The checklist on the left indicates the practices that the builder is applying. Many of these practices are already required on the site, like lock grading and drainage is already required, backwater protection, and so on. These are practices that are already required, so we can include them as achieved through our tier, but they don't actually add cost to the builder. The only measure that was in our basic checklist that was not planned to be incorporated from the outset was backup power for the sump pump and an alarm system, and that was about a $1,700 upgrade for this build. We also worked with the builder to include secondary sump pump. So this home is serviced by a sump pump. It doesn't have gravity drainage for foundation drains. So we incorporated a secondary sump pump. We also included some measures for maintenance to allow for maintenance of the foundation drainage system, like access pipes, access down pipes, and change some of the design of the foundation drainage system to reduce risk of blockage of that pipe over the life of the building. And that's an example of what's going on down here. We also looked at hail resilience for this site. And the reason why we did this is not necessarily because it's a high hail prone region, but this is our demonstration site that is the closest one to the city of Toronto, and we'll likely be bringing out insurance groups to tour this site. This was a low carbon building, so the initial proposal was that it would have vinyl siding, but we wanted to demonstrate more resilient siding practices for the site for notably hail. And because we were applying better siding, the incremental cost for better roofing was very small, so we focused on that as well. So we worked to achieve most of the basic, the good tier practices for hail protection. That includes class 4 impact resistant roof cover. In this case, we'll be using LP Smart Side in place of vinyl. There's no skylight, so that didn't apply. And we're also working with the builder to identify PV panels that can withstand hail impacts similar to the UL 2218 class 4 test for roof cover. So the PV panels and the roof cover will have a similar level of resistance to hail impacts. We've gotten most of the way to our better tier as well by adding underlayment, which we were adding for wind protection anyway. And the incremental cost of achieving these measures for the better roof cover was roughly $3,000. That's for Southern Ontario. In Calgary, we see costs more like $1,200 to $1,500 increase in price for class 4 versus unrated roof cover. The major increase in cost was moving to LP Smart Side instead of vinyl, which was about a $12,000 or $13,000 upgrade, which may not make financial sense in Southern Ontario, but it does make sense in Calgary and in other locations. We have, as I mentioned before, we're working to source PV panels that meet a similar hail resistance level as UL 2218 Class 4 shingles, which is a 32 joule impact. And there's testing that's been done by Kiowa Lab in California for impact resistance of PV panels, and we'll likely select something based on their findings. And finally, wind exposure. So this is one of the priorities of Empire. They wanted to understand options to reduce wind exposure for their buildings. They build not just in Canada, but in the US as well. So we wanted to work toward implementing the good and better tiers for wind protection. And as I mentioned before, wind protection based on CSA S520. And this part of Canada is prone to tornadoes, and also synoptic wind events, such that investment in wind resilience would likely pay for itself over the life of the building. So in our 2 tiers for wind resilience, we have different practices. The basic tier, the good tier, focuses on roof cover. The basic tier measures for roof cover. The good tier include roof cover that complies with ASTM D7158 Class G or better, which is essentially a wind gust of 100, 120 miles per hour. And essentially any laminate shingle product in Canada meets this resistance requirement, but we just want to make sure it was applied. So this was not an incremental cost because the shingles they were selecting already complied with the standard. We also are incorporating underlayment, which is about a $1,500 increase in cost over expected cost. There's some basic tier sheathing fastener requirements like 6x6 fastener patterns for roof sheathing and longer nails for roof sheathing fastening. And then also roof to wall connections, and I'll talk about that later on, but that's essentially hurricane ties or truss screws to tie the roof structure onto the building. That's our basic tier, and we were sort of easily able to comply with this tier. We also work toward application of most of the better tier measures. That included thicker roof sheathing, so they're using 7/16 inch roof sheathing. And I'll talk about the vertical load path measures that were incorporated into this building. So we focus first on roof cover as the most vulnerable part of the building to high wind and the most important driver of recurring damage. And once you address roof cover, the next most important factor is uplift resistance of a building. So we wanted to connect the roof to the upper stories of the building. We wanted to connect the upper and lower stories together, and then the entire building down to the foundation to reduce damage from uplift forces experienced during high wind events. And so we did apply measures to address this issue. And that was one of the more costly elements of this work. Is about $5,000, and I'll talk about what was done there shortly. We addressed the vertical load path, the porch roof anchoring of the building. The cladding was already addressed through application of LP Smart Slide. We did some work on windows and also on garage doors. So now some details on the vertical load path improvements. So this is one of the big areas of work over the past few months, was to work with the builder, with Simpson Strong Tie, and with Dr. Stevenson to identify a practical approach to improve the vertical load path for this building. So one of the first things that we ran into in this case was that, as I mentioned before, this is a low carbon demonstration project as well as a resilience demonstration project. So the builders were using I-joists instead of timber joists. So they didn't want to use truss screws. We had to find alternatives to truss screws because they didn't want to drive truss screws into the lower and upper chords of the I-joists because they were concerned about splitting the chords. So we worked with Simpson Strong Tie, and we identified an alternative product. It's a floor-to-floor screw that you screw through the bottom plate of the upper story into the top plate of the lower story, and you bypass the joists altogether. So the joists are not touched. We just have the structural connections going directly from the bottom plate into the top plate of the lower story. And then we use truss screws for the stud to top plate connections and stud to bottom plate connections throughout the building. We used hurricane tie, or they'll be using a hurricane tie for the roof to wall connection, roof to top upper story top plate connection, and then a combination of a threaded rod and a bolt, a specially designed bolt where the rod threads directly into the anchor bolt in the foundation, again trying to bypass screwing anything into the joist. We're going directly to the foundation through the bottom plate and sill plate for the lower story to improve anchoring of the building. I won't go into more detail, but this was somewhat of a complicated building with cantilevered overhangs and so on. So it took a fair bit of work to identify individual connections that could be made at different elements of the building for different elements of the building. So a lot of work was put into this, and we were really pleased and impressed with the team at Empire. They really spent a lot of time to understand this work and really provided, I think, a really good model for other builders that might choose to go down this path. So there's some other details here for the structural load path for the walls above the garage, the tall walls that are beside the stairwell and in the garage, and for porches and so on. And we also did some work on reinforcing the gable end walls based on the CSA S520 approaches, which is essentially a lateral brace that's installed in the roof structure for the gable end walls, and also reinforcing the outlookers, the overhangs on the gable end walls, the roof overhangs, based on IBHS practices. So one of the end results of this pilot project was a very detailed list of structural connections, connection products, and prices for this demonstration project. And this is the first time that we've seen something this detailed from a builder in Canada. So we really have a good baseline for any other builder that would like to pursue this approach with each of the connections broken out and potential products that could be applied to achieve uplift resistance for each of these connection points in the building. And the overall cost for all of these additional structural connections, all the screws, the floor-to-floor connections, the roof-to-wall connections, and so on, for this building, for the entire building, was about $5,000, but that's before labor. The status of this build as of early December, as of last week, so framing is underway currently. In the late part of November, the foundation was poured, and we worked with them through that process to make sure that we could achieve some of our goals with respect to building sewer grades, backwater valve installation and backwater valve grade, and some of the practices I mentioned before for protection of the foundation drainage system from clogs, from silt over the life of the foundation drainage system. And we'll be going back to check out the structural connections in the next few weeks or in early January. So an additional project I'll go through quickly is a MURB site in southern Calgary, the Belmont, in the Belmont area. This is the Avalon project. In this case, they were working on applying hail practices and high wind practices. They were working to apply most of the good and better tier hail protection practices, as well as class 4 roof fence as well. So aside from roof cover, also roof fence that are rated to class 4. And most of the good tier and several of the better and even best tier resilience practices for high wind will also be incorporated into these projects. In many cases, these measures were not a significant increase in cost. It was just a matter of requesting a supply from contractors. For example, as I mentioned before, high wind rated roof cover shingles, most products already comply, but underlayment and other practices were an additional cost. One final project just to notify the group of quickly is a re-roofing project that we're running with Durham Region. So the first three projects I talked about were for new construction. This is an existing construction project where we're working with roofers in Durham Region to apply wind resilient re-roofing practices for five or six or maybe a few more homes in the Durham region. In this case, we are incenting the roofing contractor directly for applying high wind rated shingles with a tighter nail fastener pattern. So 6 nails per shingle rather than the standard 4. And also encouraging installation during the warmer months, and also installing underlayment with a tighter nailing pattern. Those are the elements that we're focused on for this re-roofing project. So in the case of existing buildings, it's often more complicated, more expensive to incorporate resilience practices. And the goal of this project was to understand what we could do for wind resilience for re-roofing jobs at reasonable cost with low complexity for the roofing industry. The incremental cost for these practices that we are supplying to the roofing companies is about $4,000. And we'll have some results to share. We'll post that on our Resilient Homes Task Force website in the coming months. So as I mentioned before, the field trials were meant to verify and help us develop the resilience guidelines. So we've gotten through the design phase of the field trial projects, and we've incorporated lessons from application of our guidelines in these field trials into our guidelines that we're producing through the task force. An example of the outcomes include treating a bit more carefully some of the practices that are very difficult for builders to apply. So we're not removing them from our guidelines, but we're treating them differently. And an example of this was the Empire site is a very tight lot situation. There's not a lot of room between buildings. And so we weren't able to achieve things like downspout extensions or sump pump discharge extensions. And so we relaxed those measures. The goal here is to not have a builder walk away from a resilience project altogether because they can't achieve a few select practices. It was to get these practices on the table, help builders become aware of these practices more so than widespread application. So this is an example. We moved these more difficult practices into a different category for our resilience guidelines. And similarly for the uplift resistance in the Empire project, initially we were working with a design load related to EF2 tornadoes. And as we started looking to address that design load, it was becoming extremely expensive and difficult. And so we changed our better practices to focus on achieving an improved uplift resistance to the extent possible given time, cost, and available resources for the builder. So we're improving the uplift resistance, but we're not necessarily achieving a prescribed uplift load. And this is now our better tier for uplift resistance. And we'll also work with the builders for marketing outputs. So we don't want to just produce the technical outputs. We want to profile the builders. We want to find a way to get this information out into the building industry. So we're working with videographer. We'll produce sort of more public-oriented materials, as well as technical documentation of application of resilience practices. So our videographer will be on site when these measures are being installed, and will record. And again, the idea is to get something like the construction instruction site practical guidance for the building industry, and we'll be producing that as part of the field trials as well. And I just wanted to note that the field trial work with Chris Williams and Avalon in Calgary has already been profiled in the media. So we'll be looking for opportunities like this in the future as well with all of our field trials. So now moving on to the last part of my discussion here, ongoing work. So this is the process for development of our guidelines. I won't walk you through this. Is what I talked about in the presentation just now. Now we're in the green phase, the green circle here at the bottom, green rectangle, where we have the guidelines. They've been verified through field trials. They've been developed with input from insurers and builders. And now we're moving to a phase of sort of updating and iteration. So I wanted to really highlight that point, that the guidance documents that we produced are the first version, but they will have to be updated as they are applied by builders and insurers. So keep checking for updates if you're interested. Another important element of the work is consistency in guidance. So we are producing new guidelines, but there are already existing guidelines in the marketplace, like the NRC guidelines for wildfire, like Z 800, and so on. So one way that we want to ensure consistency in guidelines is by participating in updates and development of new standards that are being underway by federal government right now. So we want to take the field trial outputs, the guideline development outputs, and integrate it into these national standards and guides wherever possible. And so that involves us sitting on these committees, or in some cases, helping to run these committees as we're doing for the basement flood guideline standard update currently. So we do have a plan to sort of help ensure consistency across Canada of resilience guidance. I also wanted to point out the importance of something that we learned working with the building industry and insurance through this process is that the builders are looking for potential incentives from the insurance industry, and the insurance industry is looking for examples of application in the field to verify resilience options. And so what we've learned is that if we want to see wide-scale adoption of incentivization of resilience practices by insurers, we have to first facilitate field trial projects, pilot projects, so that insurers can collect data on efficacy of resilience practices. And this is an example of what happened with a few insurers, at least after the city of Calgary implemented a field trial for, or a pilot project for impact-resistant roof cover after the 2020 storm. Application of impact-resistant roof cover on about 1,600 homes allowed insurers to track and compare protected and unprotected buildings and gave them the confidence in these practices so they could start offering incentives. And so we want to find opportunities to support this sort of positive feedback loop where we have pilot projects, better data for insurers, in incentivization. This is also a path for wider scale application by insurers and builders. So last slide here, our next steps. We just had a meeting of our Resilient Homes Task Force on Monday. The advice of our task force is that this work should continue. The task force should continue. The partnership with CHBA will continue as well. We'll work, as I mentioned before, to update and iterate the guidelines and also look for opportunities to achieve recognition of the guidelines. That's part of our ongoing strategy here to make sure that these guidelines are actually applied in the field. We will continue conducting field trial projects, so we'll finish the projects we're currently running and look for opportunities for new field trial projects as well. The more field trial projects we can conduct, the better. The better refinement we'll have for our resilience practices, the better we'll understand these practices as they're applied in the field, and the more information that we can get out via field trials, the more impact we'll have in the building industry as well. One other thing to note is that there is a plan currently. There are working groups at Codes Canada looking to incorporate climate adaptation into the 2030 national building codes. But we're not expecting that all of the resilience practices that we are promoting will be incorporated into the 2030 codes. And it seems right now that wildfire practices could be pushed back even further than the 2030 codes. So this work with the building industry, looking for opportunities for voluntary adoption by builders, by insurers, looking for opportunities to market resilience, may still remain an important mechanism for application of resilience over the coming decades in absence of regulation. So it sort of signifies the importance of continuing this work, we think. And finally, I wanted to make the point about marketing. So I didn't talk too much about marketing today, but last time we talked to the Friday Forum group, we did outline some outputs from our market research studies. We're finding the best way in the early days to find marketing strategies for resilience practices will likely include working with builders directly, developing marketing report approaches directly with builders, and using those as examples for the industry. And we got a few projects that we're initiating now, but that seems to be the route forward on promoting resilience through marketing, working with builders to find opportunities to promote resilience features for their buyers and clients. So I'll end it there and I'll pass it back to Keith.
Awesome. Thanks, Dan. Let me lead off with some questions of my own. first of all, from late in your presentation, I appreciated how insurers valued the Calgary pilot, the Calgary rebate program to justify rate incentives. But that was big incentive program, millions of dollars involved, and thousands of, 1,700 homes. How many are necessary to satisfy insurers that these programs work?
Yeah, well, so I don't think we have a threshold or a number that we're trying to reach, but the more the better. So in Calgary, we had 1,600 homes that insurers could track, as well as information they were tracking on their own outside the Calgary project. But the more we talk to insurers, a dozen is better than zero, 100 is better than a dozen. So as many as we possibly can. And one of the things that we talked about with the task force on Monday was a potential pilot where one or two developers who are developing relatively large sites of a few dozen or a few hundred buildings could disclose information to insurers on resilience practices, and insurers could track those sites over a period of time, and that would give them a baseline of information they could use to make the argument in their companies that they should incent these measures. So I don't think we have a threshold number, but the more the better.
Related question from Alex Laughley, who asked, "Do you have a plan to continue with these field trials?" Can you suggest a way that attendees might support or participate in field trials like this?
Yeah, for sure. So I'm not sure who's on the line, but insurers can help by participating in the field trials. We are looking for sponsorship. The more sponsorship we get from our insurance members, and we have had sponsorship from TDI and Aviva, for example, already for some of our projects, the more projects we can do. But irrespective of sponsorship, if we can have insurers sit at the table with the builders during these design workshops, it gives them an opportunity to talk directly with the builders about how resilience practices could affect insurance coverage, and dispel some of the myths about premiums and so on, or educate them on how underwriting, how pricing, et cetera, is done at an insurance company. This is very helpful for the field trial projects, and it also helps set up a relationship between insurers and builders that we're trying to promote to develop pilot projects where insurers work directly with builders to market resilience options. So if insurers want to get involved in that way, we do have at least one way. I've got one more lined up for 2026 I can inform you of. If you're interested, just email me in Southern Ontario. That's one way you can get involved. For builders, we're looking for more opportunities to conduct pilot projects. Our offer is technical support, technical guidance. We do all the work in terms of setting up the workshops and so on. And wherever we can, we fund application of the resilience practices for the field trials. And then we work with the builder and CHBA and potentially an insurance partner to market the outputs. So there's opportunity there as well as builders.
Awesome. Here's one from our friend Becky Major at EMCR. Becky asks, is there a commitment from insurers to follow the pilot projects to gather evidence on efficacy with the intention of providing incentives down the line? Becky says, without the financial incentive, it's hard to see how homeowners will be motivated to ask for the good checklist, let alone better or best.
Yeah, it's a good point. So several insurers are currently offering incentives in some form, notably for hail resilience in Calgary. So the areas that we see incentives already, well, I'll highlight them here if I can pull up the slide, are largely for hail and basement flood protection. This is where we see incentives available already in many parts of Canada. So this chart is where we're trying to identify the measures, the hazards for which insurers are providing incentives already, and the mechanism by which they're providing incentives. So for hail in Calgary, several insurers are providing financial incentives. For water, sewer backup protection, this is fairly widely applied already by many insurers in Canada. Reduced premiums, better deductibles, higher caps, higher payout limits for flood protection, including things like backup power for sump pumps and backwater valves. Some insurers are providing incentives for wildfire protection. They're not huge incentives, but there are some incentives on the table. But we also see incentives in the form of deductibles, of sublimits. And by sublimits, I mean in cases like sewer backup and water coverage, where there's a separate endorsement for that coverage and a separate premium. If you're in a high-risk area, often the payout associated with that endorsement will be lowered unless you apply resilience practices like backwater protection, sump pumps, backup power, and so on. And so this is already being applied in Canada. Availability is an issue as well. Another big one is depreciation schedules. So for high wind, for hail, better roofing usually means that your roof depreciates slower, so you will receive a better payout later on. So my roof in Southern Ontario, the depreciation has started because it's over 10 years old. Every year it depreciates by 10%. That means my payout is lowered by 10%. If I had a better roof, if I had a high wind resistant roof, my depreciation would start at a later time, maybe after 15 or after 20 years. So I would still get a full payout after the initial depreciations would start for non-resilient materials. This is already being applied in many regions of Canada for wind and hail. So the incentives are available. The challenge is that insurers all work independently, and they have their own strategies. So often it's a one-on-one conversation with an insurance company to figure out what they're offering. This is an area of work that we want to pursue, and we've started to pursue by working with insurers and helping builders understand what to ask or what to promote to clients. So incentives are available. So the plan in terms of insurers offering incentives, it depends on how they see resilience measures reflected in their claims. So some insurers are already confident enough in Calgary to offer significant discounts for hail coverage with impact-resistant roof cover and impact-resistant siding. But they have seen the benefits of resilience practices in their claims. So what we need to do is promote application of these practices in the field and give insurers an opportunity to collect data. And we'll continue promoting with our membership the benefits of these measures. And I think we'll see more application over the years through this process.
And that actually connects to the next question from Matthew Boudreau, who asks, what are the obstacles or knowledge gaps that are slowing the long-term integration in the entire insurance industry? It's just that we're still in early days, and you see the potential for some sort of snowball effect, or are there long-term fundamental barriers that we still have to overcome?
Yeah, so I think there's a couple. There's like practical barriers. So one that many insurers have highlighted for us through this work is the difficulty that insurers have in collecting information on building characteristics. So they don't often have information available on roof cover type. Like they haven't asked their client to differentiate if they have class 4 or high wind resistant roof cover. They might know the age of the roof, but they don't know much about the materials. And that information is not often disclosed or included in service provider information that they use for underwriting. So that's one barrier. The other important barrier is this whole efficacy issue. So I would differentiate two types of information that prove efficacy to us. There is performance information based on lab testing, based on field investigations, based on engineering performance information. That is robust information that gives us as researchers, as those promoting these practices, confidence that these measures will reduce risk. And that's the case for wildfire protection, for hail protection, for wind protection. We know that a better continuous load path will reduce risk during a high wind event based on engineering studies, based on engineering calculations. That information does not translate to an insurance company underwriting department well. They need to see information in claims. They need to look back at their claims. This is what they're telling us, and see a difference between the building in Calgary that had hail protective roof cover and siding and a neighboring building that didn't. And they need to compare claims on a mass scale and generate statistics in order to give themselves the confidence they need to offer incentives. So I think those are the two major barriers. There's practical barriers about disclosure of information, and then there's this difference between performance and engineering data and claims data that has to be closed.
Great. Our friend Slobodan Simonovic says, thanks for your presentation. And he points out that there's parallel research going on at the National Research Council into building resilient sustainability, addressing climate change impacts, updating building codes with future climate data, et cetera. Point is, I think his point is that we aren't the only ones doing stuff like this. The NRC is working along these lines. Are we collaborating with NRC, or how are we coordinating or aligning our research with theirs?
Yeah, so the guidelines is actually a project of NRC. They're funding development of the guidelines, and we're coordinating with their buildings team. We're also applying the outputs of that work in these guidelines. So we're working directly with them on these projects. And I would say the major difference between what we're doing here and what NRC is doing is that we're working with the building industry directly on application of these measures and understanding the practical aspect of application of the measures that they have produced and issued through the standards and guidelines like the NRC Wildfire Guide. So the NRC Wildfire Guide was produced, we sat on the committee for that as well. It was produced by fire engineers. They were design load objectives and so on that were used to produce those guidelines. But it was not produced in the context of a building company actually applying the measures. And so the input that we're providing to the process of resilience is, what can we actually do in the field? How do we tailor these measures so that builders can actually apply them? And this is all coming from our experience over the past 10 years, having been involved in developing these guidelines, but seeing essentially no uptake of the guidelines, or very, very limited uptake, and attempting to work with building associations and builders, presenting the material, presenting the standards, and getting strong resistance. So our goal here was to work directly with them, respond to their concerns, respond to their feedback, convert the guidelines. We haven't lost anything in the guidelines, but we've converted it into something they can apply in the field. And in terms of construction codes, part of what we're doing is providing practical implementation in the field that will affect how these measures are potentially brought into code. Because we can't introduce measures into construction codes that the building industry can't comply with. They will just get massive pushback. That's been our experience, again, to date. Anytime that we've attempted to pursue code change requests without verification in the field, is we get massive resistance. So it's meant to smooth that process, the long run process of integrating resilience into policy in Canada.
Cool. Michelle Hu, sorry, Michelle, if I mispronounced that, asks about access to the guidelines. Would you mind coming back to the link that you've got there, to
Sure.
the URL to the guidelines?
So the link is here, iclr.org/resilient homes task force. Currently, we have hail, high wind, and basement flood posted. We're nearing completion of wildfire. We hope to have that posted before the end of the year or early next year. And everything's in English now, will be translated also early next year.
Awesome. Another question from Becky Major. Is there also connection in with Build Canada Homes to adopt these measures?
Yeah, well, that's a good question. So we did, when they said they had a call for feedback to their implementation framework, and we did provide guidance concerning resilience. The call is currently open, and they do include resilience as a criteria for selection of projects. My understanding is that there are not specific criteria for resilience, but projects that include resilience will be a factor in selection of projects through Build Canada Homes. Developers will approach Build Canada Homes with their proposed projects, and it's kind of up to them to decide how resilience is incorporated, and they have to make an argument that they've incorporated resilience. So our hope is that working with the construction industry through CHBA, working with our task force members, working with several other partners in Canada now, is that we can offer these guidelines through the building industry associations, and they potentially would be used to help achieve that criteria that's been included in the Build Canada Homes call.
Awesome. Alex Laughley asked follow-up. Is there a plan for the technical docs to bridge the gap from new construction to rebuild, addressing some of the needs of insurers? In other words, do you want to sort of plug Glenn's good, better, best guidance for existing buildings?
Yeah, so we do. We have some guidance for more homeowner-oriented good, better, best guidance, and it was really based on this guidance, but very, very much simplified. It's often much more difficult, more expensive to implement practices like this in existing construction. So we do have some practices available, but we also plan to continue working with CHBA with their renovator members to find a way to make this usable by renovators as well. And Keith may have a different opinion, but probably what we're working toward is windows of opportunity for existing construction, like maintenance, like when you're getting your roof replaced, like we're doing with Durham Region, the roofing pilot project after a loss, so Build Back Better opportunities. These sort of windows of opportunities is likely where we're going to get the most traction in application for existing buildings. So these materials are available, and we do have a renovator on our task force who is aware of these materials. It's all totally voluntary, so a renovator could partially apply these practices. It's up to them. But we do have a plan to work, I think, through CHBA and their renovator members to tailor these specifically for existing construction. And I would also keep the door open for renovation contractors to work with us to refine these measures for their use as well.
Yeah, no disagreement about the most opportune times to improve buildings. It's when people have money. At the time of construction, and then when they're getting a lump of cash to repair damage, their minds are focused at that time. I mean, ICLR is looking at other times when we might be able to convince people to do climate adaptation. I just think that Dan's right about when the most likely times are that people are going to be open to doing this stuff. About the volume of stuff, this is a question from me. The sheet that we're seeing right now, the slide that we're seeing right now shows 128 technical sheets, and we may have people on the attendees thinking, oh my God, what is my entry point for that? There's a lot of documents and it may be overwhelming. You know a lot of the people who are attending today, who our members are and what their interests are. Can you name some other use cases or some use cases where, I mean, you've said, okay, well, you want to use this stuff, maybe join us in meetings with builders to promote, pilot studies. Can you name one or two other kind of ways that people on the call today could engage in this material and like do something practical with it over the next few months, other than what you've already pointed out?
Yeah, well, so I think in terms of the volume of material, so there's a lot of material, but there's no intention that any individual is going to review all of the measures or all of the technical sheets. The intention here is that a user is going to go to the checklist first, and the checklists are meant to be very simple. So if you are a homeowner builder in Calgary, you can grab the checklist and look at it very quickly. And that's been our experience to date, is that we can sit down with a builder, we can look at the plans for a specific site and very quickly work our way through the checklist. Here are some characteristics of this building. You've already met this criteria, et cetera, et cetera. In many cases, you don't need to go to the technical sheet to understand what the measure is. It's very simple, like class 4 roof cover. All you gotta do is call your supplier and say, I would like UL 2218 class 4. That's been our experience to date. The technical material is there if you have a question, or if you need more information, or if you're looking to actually install the measures or source the measures, like if you're really seriously getting into application of the measures. The measures, the guidelines really are designed for the building industry, I would say. We really were trying to respond to the needs of home building company owners as those who would make the decision of whether or not to pursue a progressive practice, or potentially an insurance company executive who might decide whether or not they want to incorporate these practices into underwriting or a Build Back Better program. That's what they're designed for. But I think any member of the public could take the guidelines, the checklists, and look at their own building and fill them out. I mean, they're meant to be very, very simple. I would also hope, like, these are newly released and we're looking for opportunities to apply them. But I would hope that an insurance company, if you are working with your clients to encourage resilience, you could inform them of the existence of this basic hail protection checklist when they're getting their siding redone, when they're getting their roof cover redone. Here is what you should ask your roofing company for. In the simplest way possible, here are some basic practices that you could look to request from your roofing company. So I don't think we've explored all potential use cases, but they were meant to be very, very simply presented. And presenting to a building company owner, really, we were aiming our language to be like public oriented, simple as possible, non-technical. So I would encourage anybody on the call, like, don't look at all the materials, start with the good checklists for each of those hazards and work your way up from there.
And I would suggest like an easy way to engage quickly is perhaps think about your own home. Think about what peril you're worried about for your house. Download the good checklist for that. Look at it. Might make it more sort of tangible, relatable, and that might be a really useful, easy entry point to this big stack of documents.
Sure.
Becky Major asks another question. We've spoken mostly about insurers and builders. Becky wants to know, are you also talking to building material suppliers? Becky's heard an anecdote from Kamloops that even though someone wanted to adopt fire smart measures, they couldn't find the recommended 3mm vents at any home hardware store in Canada.
Right. Yes. So we have a 5-year plan at ICLR. So that I'm presenting only 2 outputs of the task force, which are the guidelines and the field trials. We have a 5-year plan at ICLR for new home construction that includes more interaction with manufacturers. And I think the best way it seems to get meaningful feedback and meaningful input and commitments from the major players in the construction industry is through the field trials, giving them specific examples where they can apply their materials, and then the marketing opportunities that come from the field trials. That's one of the major ways that we are currently or plan to engage with manufacturers. So that's why we asked LP SmartSide, we asked ICO, we asked Simpson to become involved in the field trial, for example. For manufacturers, we've also heard that there's trouble, people have trouble finding materials. For screening events specifically, there are manufacturers largely in the US who produce products, Vulcan Vents. They actually sent us some examples recently that I shared with Keith that we'll have at our demonstration sites and the demonstration centers. What they want is demand from the market. If there's demand from builders, from the building industry, they'll ship product up here. The reason why they're not shipping it is because nobody's asking for it. So we have to help generate that demand, and that will help the manufacturers promote their measures. We also have become involved in some projects with manufacturers directly where they have roofing systems or siding systems that are more resilient, and we can help promote them with our sort of backed up by ICLR, apply these practices because they improve resilience. It's not just us saying it. It's backed up by an insurance industry associated group. That's an opportunity as well. But we'll only really see a big shift in that market once we have demand for their products.
I want to highlight a distinction that we're going to talk about in next month's Friday Forum. You talked about costs, and I want to highlight the distinction between the builder costs and the home buyer, the price sold to the price at which that home is sold to the buyer. Now, common sense conventional wisdom says that a dollar increase in costs to the builder means a dollar increase in costs to the home buyer, and the commensurate decrease in affordability. Next month's Friday Forum is going to talk about that, and we're going to talk about Kevin Simmons's previous work in Moore, Oklahoma, that says maybe it's not a dollar of increase in purchase price for every dollar increase in, for an added truss screw or something. I don't want you to sort of agree or disagree on that point, but tell us something about how strongly builders believe that, and why some builders might agree and why some builders might disagree.
Yeah. So there's no doubt that there is some added cost in many cases for the materials we're promoting. In Calgary, where there are some insurers at least that are offering incentives, the incremental cost of Class 4 shingles and even something like LP SmartSide, which is like a $10,000 potentially upgrade over vinyl, is covered by premium reductions, especially in high risk or high hazard areas of Calgary. So that cost is offset in some cases at least. And our field trial participant, Chris Williams from Avalon in Calgary, has told us he's a net zero builder. He builds net zero homes because the incremental upfront cost of net zero practices like better insulation, HVAC systems, and so on is offset by the savings on energy bills. So the higher mortgage cost over your 25-year mortgage, monthly cost is lower than the savings from energy bills. And so he says, we just apply the practices, we don't even ask. And if we can get to the same state with reduced coverage cost of insurance, we'll apply resilience practices as well. So that's one thing that I've heard from builders. The other thing is that if builders find a way to market the options, they're not so much worried about cost. If they can sell as a market advantage a resilient home, they see that as a potential competitive advantage. And I'm hoping in the next few years, we've been talking with a major builder in Calgary who's building out sites in northeast Calgary, that if we can get a few homes constructed in northeast Calgary with hail resilient practices, they will be situated side by side with non-resilient homes. After the next hail event, homeowners, home buyers, people looking to buy in that area will be able to see the difference between a non-resilient and a resilient home, and they will be more willing to pay the small incremental cost of these practices. And this is what they saw for example, PV panels. They started installing PV panels. New home buyers saw the PV panels. They said, hey, I'd like to have that on my home as well. They were able to make an argument with respect to reduced energy cost, and now they offer them by default in all their homes in Calgary. So that's the trajectory we would like to see. So the cost is not really the concern, it's the marketability. It's the buyer perspective that we need to address.
Awesome. We are near the end. Do you have any last, burning thoughts that you want to leave our attendees with?
No, I don't think so. Thanks, Keith, for the opportunity and for all your support too over the past couple of years. And if anybody on the line is interested in this work, feel free to reach out. We're always looking for partners, so let us know. Awesome.
I want to remind everybody that today's presentation, Dan's the recording, Dan's deck, and transcript are going to be at our website at www.iclr.org/workshops within the next few hours, but certainly by Monday. And I want to remind you about that next month's Friday Forum that I've plugged twice already today. That's on January the 9th, 2026, when we're going to hear about building codes, construction costs, and purchase price. We're going to have this interesting panel discussion where our speakers will give a presentation, and then Dan and our colleague Kevin Simmons are going to join us for a conversation about the broader implications of that research. So if you are not yet on our mailing list to find out about that seminar, subscribe to our mailing list. You will, if you search ICLR.org and the word subscribe, that will take you to a place where you can sign up for the mailing list, and you'll get an email inviting you to register for that webinar. In the meantime, I hope everybody has lovely holidays. Stay warm, stay safe, and we will see you in the new year. Thanks, everyone. Thanks, Dan.
Okay, thank you.